Hello and welcome to our next topic. This is the level sensor, resistive level sensor. Okay, how it is working. You see, basically we do have a PCB, a printed circuit board. Okay. On one side there are two. It looks a little bit like a fork or whatever. However, there are two different things. Yeah, every second copper thing is connected to each other, and the other second copper thing is also connected all to each other. So basically there are two poles. Yeah? And how this is working is simple. This is working, we just measure the resistance between one and the other. Okay, so there is also a resistor on there. It's nothing more than the measurement with the potentiometer we have done, or the light measurement, or the brightness measurement, or the temperature measurement with the NTC, as you remember. This functions exactly the same way. The thing is that if it is then covered by some liquid, yeah, and this liquid needs to be, if it's not covered with liquid, there is no connection between the two. And if it's covered by a conductive liquid, okay, water is conductive enough, yeah, then there is a resistance, and the bigger the part, the share of the sensor which is covered, the lower is the resistance, because the better the electrons get from one side to the other, because there's simply more room for them. This is how this thing is working. Okay. We do have three connectors. There is plus and minus, 5 volt, ground, and there's S, the signal. This is the analog output which we have to measure with our Arduino. And that's it. Yeah? Nothing more, nothing less. Yeah? One thing needs to be mentioned. This is a brand new sensor. Yeah? Once it is used, it looks like this. Yeah? You see, every second is not that shiny anymore. Why is this? Because basically the conductive liquid, yeah, it's basically ionized. Yeah, so the ions which transport the electricity, and these ions, are atoms. So there is material which is transported, and you can see that the copper things are getting dissolved over time. That's an issue with such kind of sensors. Yeah? They simply will go away, dissolve in the liquid which is covering them, because it's ionic current. Yeah? And then of course there's another resistance anyway, and this causing a drift on this type of sensors. Okay? But let's come to the hardware setup. Basically, we just need four things again: plus minus signal, plus is white, minus is black, and signal is gray in this case. There's my Arduino. Plus and minus, plus is going to plus 5 volt, minus is going to ground, and the signal is going to analog input 0. Okay. Now again have the issue with the cable. Is it covered? Yes, it is covered. Plug it in. Pimpelim. We're ready to go. Okay, we're ready to go and see what we can read out of this sensor. There is even a light on it. Everywhere has to be a light on. Of course, we start again by saving it on the proper name. This time we are at 37. I'll call it level. Good. Define level in, and that's analog input 0. However, I don't really need much things here, and I will just write here 0.begin 9600. Use the right bracket hands, and then I start to measure. Yeah. What do I measure? I do measure integer, ana in, analog read, analog read from this sensor. And as you remember, we are reading here values between 0 and 1023. Yeah? And I will just 0.print input. Just want to write it out in percent. Yeah? 0.print. Now I do something which is called cast, typecast, yeah? Because I do want to have this as floating point value. So I can simply say float and use ana in, and then suddenly ana in is transferred into a float, yeah? And then I will divide by 10.23 because then I have it in percent. Huh? And I want to have it with 2 digits. This is how this is written. And then I need a print line percent. Okay. And not to that I'm not printing out too much, I will simply delay. That's all. It's basically just reading in an analog input. Yeah. Let's see what this is doing. %. Okay. Now I'm touching this. I am now with my finger. I will simulate some liquid. 0.8%. Yeah. Now I cover more. 3%, 4%. Yeah. It really seems to work. Yeah. Then there is the rest of my finger. Now I just use here my drinking glass. Now I have wet fingers, yeah, and see if this is, 20%, 25%. So with wet fingers, the conduction is much better. Yeah? And now I let it go, and you see it stays at 24%. Why? Because there are drips on it. Yeah? Let's make it a little bit bigger, yeah, or even very big. You see there are some drops on it, and these are enough that we can read it. Yeah? So for instance, if we want to distinguish if it's raining or not, we can simply place something like this, yeah? And if we are above a certain value on our reading, yeah, then we say, there are raindrops, we have to close the window or whatever, yeah? We have to react on this, yeah? Or pull in the marquise, I don't know, the sunroof, yeah? Or close on the door in the car, close the sunroof, yeah? Or turn on the wiper, something like that. Then the wiper the wiper is turned on, it will wipe off from here, and it is decreased, as you see. Yeah, and then we can wipe it dry again. We can wait until this is dry, then we should get below, or we can wipe it dry, then we are at 0 again. This is just tissue. So once again, I will make a drip on it with some water simply. I will make a little bit more drips on it. You see, we are 30% now. Just take a look how they are looking, drips. You see they are on there. Yeah, and this is how this is working. Like I said, the only issue we really have with this type is that we are dissolving this. Here again, the comparison between those two. We are dissolving this. Maybe you can come up with a solution how to minimize this dissolving. How to minimize this dissolving. This would be interesting. And to show you how fast this is really going. This was a brand new sensor, right? This was a brand new sensor. And now look at it. There are already some marks. These few minutes left already marks on our new sensor. So there must be a solution, because this is used in reality. But of course, you see, they are not very intense, and only there if you look at the angle, but they are there. There must be a solution for this. Think about what might be the solution. This is the task. Again, ghost in the machinery you have seen moved. So think about this. There is a solution. There's a solution. Come up with a solution. Since I cannot show you the solution because it pretty much looks the same, this is it for this time. Next time we're going to talk about a peer sensor, movement sensor. We'll learn how this is working and how we can incorporate this in our Arduino device. For this time, thank you very much for listening, and goodbye.